Okay, guys, in this lesson, we're going to learn how to transform exponential functions. Recall that our most basic equation for exponential functions is f of x equals ab to the x, where b is your multiplier and a is your initial value. And when we have the form f of x equals ab to the x, our a was also our y-intercept. Now we're going to take a look at some functions, some more exponential functions, but these are going to be a little bit more unique. We're going to change the a value from 1 to other values. We're also going to be adding and subtracting from the x variable. We will also be adding and subtracting from our exponential term. Here is a summary of all the transformations that we'll be looking at for this lesson. Let's go through each of these. So here we have the parent function, f of x equals 2 to the x, and we're going to be transforming this parent function, and we're going to start by looking at what happens when we add to the exponential term. So 2 to the x is our exponential term. So let's take a look to see what is going to happen to our red parent function when we add 3. Also notice that our asymptote is y equals 0. So let's take a look using green. So this function table is going to represent the values for 2 to the x plus 3. So when I plug in -2, we get 1/4, and then we add 3. So this is going to be 3 and 1/4. When I plug in -1, I get 1/2, and I add 3, and I got 3 and 1/2. When we plug in 0, we get 1 plus 3 is 4. When I plug in 1, we get 2 plus 3 is 5. And when I plug in 2, 2 squared is 4, plus 3 is 7. And now we can graph these points. I'm going to start with 2, 7. And then we have 1, 5. And then we have 0, 4. So you can see how each of these points are shifting up by 3. And then we have -1, and then 3.5. And then we have -2, 3, and 1/4. Also notice that the asymptote has also shifted up 3 units. Now let's take a look at when we have a k value that is -3. So we're going to plug in -2. So this is going to be our purple graph. When we plug in -2, 2 to the -2 is 1/4, -3. So that is going to give us negative. So we have 1/4 minus 3 gives us -2 and 3/4. Then we plug in a -1 and get 1/2. 1/2 minus 3 is -2 and 1/2. Then we plug in 0 for x, and we get 1 minus 3 is -2. We plug in 1. 2 to the 1 is 2, minus 3 is -1. And when I plug in 2, I get 4 minus 3 is 1. So let's plot these points. So we have 2, 1, and then we have 1, -1, and then we have 0, -2. We have -1, 2.5, and we have -2 at 2 and 3/4. We also notice our asymptote is going to be y equals -3. Notice that each of these points shifted down 3. Everything shifted down 3 along with our asymptote. So you can see that whenever the k value is something other than 0, our graph is going to shift that many units. So if we have +3, it shifts up 3. If it's -3, we shift down 3. Also, our asymptote shifts along with the graph. Here is a summary. When k is more than 0, we shift up. Whenever k is less than 0, we shift down vertically. Now pause the video and see what kind of shift we have in each of these examples. Remember, you're only looking at the k value, which is the value that's added to the exponential term. Number 1, we have a vertical shift down. Our asymptote is y equals -5. In number 2, we have a shift up 3 units. Our asymptote is y equals 3. Number 3, we have a shift up, and our asymptote is y equals 1. In number 4, we have a vertical shift, and it is going down 4 units. Our asymptote is y equals -4. Number 5, we have a shift down 3 units with an asymptote of y equals -3. Number 6, we have a vertical shift up 6 units. Our asymptote is y equals 6. The shift up and down will also affect your range. Now let's take a look at when we are adding or subtracting from the x variable. Now make sure you notice in the formula that we have f of x equals a times b to the x minus h plus k. So anytime in your formula, just like with our slope formula, y2 minus y1 over x2 minus x1, remember that our subtract is going to indicate the opposite of. So let's get started. We have our red parent function graphed. The asymptote again is y equals 0. Now let's graph when our h, this is going to be a horizontal shift, but our h value. So when we plug in -2, I have -2 minus 3. -2 minus 3 is -5. So I have 2 to the -5th. Which is going to be 1 over 2 to the 5th, which is 32. Now I'm going to plug in -1. When I plug in -1, I get 2, -1 minus 3 is -4, and we get 1 over 16. When I plug in 0, I get -3, 2 to the -3. This is going to be 1 over 8. When we plug in 1, we get 2 to the -2, which is going to be 1 over 4. And when we plug in 2, we're going to have 2. When I plug in 2 for x, I get 2 to the -1, which is going to be 1/2. Now let's plot these. So -2 very small here, 1 1/3. Then we have -1, 1/16, 0, 1/8. Then we have 1, 1/4. And then we have 2, 1/2. And then we are going to draw our graph. And you can see that our graph has actually shifted to the right. Now let's take a look at when we add 3 to the x. So this time we're going to plug in -2. -2 plus 3 is 1. So 2 to the 1 is 2. Then we're going to plug in -1. That's going to be 2 to the second, which is 4. Then we plug in 0 for x. We have 2 to the third, which is 8. Then we plug in 1. 1 plus 3 is 4. 2 to the fourth is 16. And then we plug in 2. 2 plus 3 is 5, and that's going to give us 32. So let's graph as many points as we can with our limited amount of coordinate plane. So I have -2, 2. I have -1, 4. We have 0, 8. And that's about all we can plot on this coordinate plane. But you can see that our graph has been shifted to the left. So guys, make sure that you understand when it is x plus 3, when we're adding, we're going to go to the left. Our graph is shifting left. When we subtract from the x, we're going to shift to the right. This is opposite of what we intuitively think. So our intuition says, oh, -3, let's go left. That is not correct. So make sure that you take note that when we subtract from x, we shift right. When we add to x, we shift left. Okay, let's determine which way we are shifting and identify the asymptote. Now, I do want to recall that when we only, let's just back up, when we only shift left and right, our asymptote stayed the same. So your H value does not affect the asymptote. So far, we've only discovered that the K value affects the asymptote. So here, again, we're only going to look at what's been added or subtracted from x to tell us if we have a left or right shift. So remember, it's the opposite of what you naturally would think. So when we add, we are going to be shifting left 4 units. My asymptote is y equals -5. But this value had nothing to do with our asymptote, only the k. In number 2, when you subtract, you are going to shift to the right 6 units. Our asymptote is y equals 3. In number 3, when we subtract, we're going to go to the right 2 units. Our asymptote is y equals 1. Number 4, when we add to the x, we are shifting left. In this case, 5 units. Our asymptote is y equals -4. In number 5, when we subtract, we are shifting to the right. 1 unit in this example. Our asymptote is y equals -3. And our last one, again, when you add your shifting left, we're going to shift left 1 unit. Our asymptote is our k value, which is y equals 6. Again, the k value is what changes our asymptote, as well as the range. Okay, now let's go on to the a in our equation. So when we looked at ab to the x, f of x equals ab to the x, our examples was a was 1, just like our parent function. We have an understood 1 here. Our b value was 2 raised to the x. Now we're going to focus only when our a is negative. So here my a value is -1. Let's see what happens. When I plug in -2, so I have a negative and then 2 to the -2. I still have a -1, and now I have 2 squared on the bottom, so I get -1/4. When I plug in -1, I still have my negative out front, so that's going to be the -1. This negative exponent tells me I need to take my b factor, my base, to the denominator, and now I have -1/2. When we plug in 0, I have 2 to the 0 is 1, times this negative, I get -1. When I plug in 1, I have 2 to the first, which is 2, times this negative. Remember the order of operations. You do your exponents first and then multiply. So this was 2 to the 1, which is 2, times -1, -2. Here I have 2 squared, which is 4, times -1, -4. Now we're going to plot these. I have -2, -1/4, -1, -1/2, 0, -1, 1, -2, and 2, -4. Our asymptote, y equals 0, remained the same, but our graph reflected across the x-axis, y equals 0. This is a vertical reflection. So when your a value is negative, your graph reflects vertically. So when a is less than 0, meaning a is a negative, let's put that in quotes, a is a negative value, the graph reflects vertically. So let's determine which of these reflect. Number 1 is a vertical reflection with an asymptote of y equals -5. Number 2 does not reflect. Number 3 does not reflect. Let's write in these asymptotes. Number 4, it is a vertical reflection. The a is negative. My asymptote is y equals -4. Number 5 does not reflect. It has an asymptote of y equals -3. And number 6 reflects, and it has an asymptote of y equals 6. Now, the ones that reflect will be reflecting across your asymptote. So when a is negative, you have a vertical reflection. Now let's look to see when our a value is more than 1. So when I put in -2, I'm going to have 3 times 2 to the -2 is 1/4, and I get 3/4. When I plug in -1. 2 to the -1 is 1/2, and we get 3/2. When we plug in 0, I get 3 times 1, which is 3. When I plug in 1, I get 2 to the first is 2 times 3 is 6. And then 2 squared is 4. 4 times 3 is 12. So let's see what is happening here. So -2 and 3/4, -1 and 3/2, which is 1 and 1/2, 0, 3, and 1, 6, and 2, we can kind of just sketch it in up here. So when your value A, and if it were negative, that only talks about the reflection, but the absolute value of A is if it's more than 1, we have a vertical stretch. That means our graph increases even quicker than when our A is 1. It's kind of like having a very steep slope. So if you want, you can just think of this A. It's kind of like your slope. It increases quickly if our A value is more than 1. So we call this a vertical stretch. It's being stretched or pulled up. All these points are being stretched up. My graph is increasing very quickly. So again, if your A is negative, just disregard the negative and just look to see if that absolute value is more than 1. If it is, you have a vertical stretch. Now let's take a look to see when our value A is between 0 and 1. Let's see what happens. When we plug in -2 for x, we get 1/4. This gives us 1/8. When we plug in -1 for x, we get 1/2. 1/2 times 1/2 is 1/4. When we plug in 0 for x, 2 to the 0 is 1, we get 1/2. When we plug in 1 for x, we get 2. 1/2 times 2 is 1. And then 2 squared is 4, and 4 times 1/2 is 2. So now let's graph these points. So -2/1/8, kind of hard to plot that. -1/4, 0 1/2, 1 1, 2 2. And here you can see, if you notice, that instead of going up quickly when A was more than 1, this is being compressed. So we have a compression when A is between 0 and 1. Some folks call it shrink, a vertical shrink. So a shrink or compression is kind of like someone's pushed down on our parent function and made it made it go out more gradually. It's being compressed. So when you're A, again, if it's negative, just disregard the negative. That only talks about the reflection. If it is between 0 and 1, it's called a vertical compression, or, as we said, a vertical shrink. Compression and shrink mean the same thing. So our A value tells us if we are reflecting or not. It tells us if we are going to have a vertical stretch, if it's more than 1, and we have a vertical compression if it's between 0 and 1. So let's look at these. Again, we're just looking at the A value. So here, this 1/2 tells us that we have a vertical compression. asymptote y equals -5. Number 2, 3/2 is more than 1, so we have a vertical stretch. It's going up quickly. Our asymptote y equals 3. Number 3, our a value is more than 1, so this is a vertical stretch. Number 4, my a value, 2/3, is between 0 and 1, so we have a vertical compression or a vertical shrink. Asymptote y equals -4. 5/3 is more than 1, therefore this is a vertical stretch. Asymptote y equals -3. 7/8 is going to be a vertical compression or a vertical shrink. Asymptote y equals 6. Now let me just show you an example. If you have f of x equals negative, let's just say 2, with a base of 2 raised to the x. Let's just keep it simple. The negative tells us it reflects across y equals 0. This 2, the absolute value of -2, is 2, which is more than 1. So this would be a vertical stretch. We would have a vertical stretch and a vertical reflection because of the negative. Here is a summary. Make sure you have this in your notes. And remember, when you have a shift, it is the opposite of what you would naturally think. If our base is 2 and we add a number, this is going to be a shift to the left. If we have a value subtracted from x, we are going to have a shift to the right.